Hi everybody! So now that we've learned all of these exponent rules, on day 4 of our chapter, we're going to go ahead and learn about how we can combine them. Now, I've taught this for 11 years, and what I've realized is that this seems to be a very challenging idea because there are so many different options of ways to do these problems correctly. So I thought it might be a good idea in our notes to have multiple ways to do these problems. Now, we're going to do each of these problems 2 different ways, but that doesn't mean those are the only 2 ways to do these questions. You could definitely simplify these problems in lots and lots of different ways and be correct. So feel free to experiment and to play around and do what makes sense to you in your brain. So let's do problem 1 in at least 2 different ways. I'm going to go ahead and copy the original problem into this box so that I have some space to do some work. The first thing I see here is that I have a 0 power and I have some parentheses. So right away what I'm going to do is I'm going to say, well, I know something to the 0 power just becomes a 1. So I can simplify this by saying this is equivalent to 2x to the 3rd to the 5th power because that second part of my problem just becomes a 1. Then I'm noticing I have a parentheses with an exponent on the outside. So I'm going to go ahead and distribute that exponent. When I do that, my new problem would say 2 to the 5th power times x to the 15th power. Again, I'm still not all the way done. I want to simplify as much as possible, so I'm going to go ahead and simplify 2 to the 5th power. So my new answer would be 2 to the 5th power, which is 32, and then x to the 15th power. I can't see anything else here that I would be able to simplify, so I'm going to go ahead and stop there, and I'm done. Now let's see if we can think of another way to do this problem that would have given us the same answer. So I could start this problem, instead of realizing that this was a 0 and turning it into a 1 right away, I could start this problem by just saying, listen, I'm going to distribute first because I like distributing, it gets rid of parentheses. If I distributed on the first parentheses and the second parentheses, here's what I would get. I would have 2 to the 5th power times x to the 15th power times 4 to the 0 power times x to the 0 power. Then I might realize that, hey, I've got some 0 power stuff going on here. Anything to the 0 power is going to turn into a 1. And 1 times 1 is just 1. So my new problem is just 2 to the 5th times x to the 15th. And then I might say to myself, well, I know I need to simplify some numbers if I can. So since 2 to the 15th is really 32, my simplified answer would be 32x to the 15th. And I'm done. Either way, I would get the same answer. It's just a matter of preference, which one makes more sense to you and which one you see first, which rule you decide to apply first. Now let's take a look at problem 2. So if I'm going to simplify problem 2, I'm going to start by copying it down just to be able to show some work and show everybody what's happening. I'm sorry. So the first thing I notice right away is that I have a power outside of the parentheses. So I would maybe start by distributing that power to everything that's on the inside, which means I would have 2 to the 2nd power times x to the 6th power. And then I'm just going to copy down the x to the 4th power because I haven't changed anything. I'm just going to write it down. Then I might say to myself, well, I know that 2 to the 2nd power can be simplified. So I could simplify that to 4, and then I still have x to the 6th power and x to the 4th power. And then I might think to myself, hey, these have the same base. If I have the same base and I'm doing a multiplication problem, I can just add the exponents. So my answer would be 4x to the 10th power, and I would be done. Now let's say I saw this a little bit differently. Maybe I write down this problem and I panic and I can't remember a lot of the rules that I've learned. Another option that you have, instead of just doing the same rules in a different order, is write the whole thing out. So we know that 2x to the third power squared really means 2x to the third power times 2x to the third power, and then I would just copy down the x to the fourth. Now, if I want to simplify that, I could continue expanding it, in which case, so I'm going to give you kind of like two options from here. So option 1 would be continue expanding that. So I could expand it and I could make 2 times x times x times x, and I could make it times 2 times x times x times x. So that's this one and this one. And then I could do times x times x times x times x from these four. And then I could simplify and I could say, well, 2 times 2 would be 4. And total, I'm going to have 3 plus 3 more plus 4 more x's, so x to the 10th. And that would give me the same answer that I got here. Now, option number 2, if you don't want to write the whole thing out, would be, okay, well, you got to here. We're going to pretend we're back here now. You got to here. Now we could say, hey, you know what? I remember one of these rules. One of the rules was that if you're multiplying, you just add the powers. So if I add those powers, because they all have the same base, I get x to the 10th. And if I multiply these numbers, 2 times 2, I get 4. And I'm done. And I would get the same answer. In this problem, we really just looked at 3 different ways to get the same answer, just depending on your preferences and how you see things and how your brain processes everything. And we all know that our brains work differently, and that's okay. You have some options here, and you need to do whatever makes the most sense to you. Let's go ahead and look at another example. So in problem number 3, when I'm trying to simplify this, I'm going to go ahead and copy that down just so I can do some work. And I can still read the original problem so that when I do it a second way, I can see what's going on. So the first thing I notice here is that I have a parentheses with an exponent on the outside. Now, I'm a rules person. I like rules. So I'm going to go ahead and distribute that power to everything inside of there. So my new problem is going to say 2 to the third power, s to the third power, over 3 to the third power, t to the third power. Now there's nothing to distribute for the second parentheses, which means we don't really need the parentheses. So I'm going to copy that down without parentheses. Now I could simplify this. So I could say to myself, hey, 2 to the third power and 3 to the third power are just numbers. So I could simplify that and I could make 8 s to the third power over 27 t to the third power times, I'm just going to copy the second part of this problem, the second factor down. Then I could say to myself, well, I know some rules about multiplying fractions. I know that when I multiply a fraction, I can just go straight across the top and straight across the bottom. So when I multiply these fractions together, I'm going to have 8s cubed t to the 5th divided by, now I notice there's a 27 and a 16, so I'm going to multiply those numbers together. So 432 t to the third power. The last thing I'm going to check to see is if I can simplify anything. So if I ask myself, can anything be simplified? Well, let's check the numbers first. I don't know whether 8 goes into 432 or not. So on my calculator, I would type in a fraction where there's an 8 on the top and a 432 on the bottom, and I would get 1 over 54. That tells me that in my answer in the fraction, I'm going to have a 1 on the top and a 54 on the bottom. That's going to simplify. So that comes from here. Then I'm going to look at my variables. I see that on the top I have a base of s, and there are no other s bases anywhere in the problem, so that's not going to change. I'm just going to copy it over. And then I notice that I have two different pieces of this fraction that both have a base of t. Now, those are being divided. One of them's on the top, one of them's on the bottom. That's a division problem. So the rule for that would be that I would subtract the powers, and I would get t squared. I always do the top minus the bottom, so t to the positive 2. Now, when I look at that, there's nothing else that can simplify. That would be my final answer. Now, what if you didn't see it that way at all? What if you go back to the original problem and you're like, I would not have done it that way? Well, let's see if we can do it a different way and still get the same answer. So another option you have here is just write everything out from the get-go. So you could rewrite this as, instead of this guy, you could rewrite it as 2s over 3t times 2s over 3t times 2s over 3t, and then you could just copy down the t to the 5th over 16. And then you could say, well, I know a rule for fractions. I just go straight across, and when I do that, I'm going to combine all the 2's. So 2 times 2 times 2 would be 8. I'm going to combine all the s's, so s times another s times another s would be s cubed. And then I've also got this t to the 5th hanging out up there. And then you could combine a bunch of stuff on the bottom. So you could say, well, I'm going to combine all the 3's, 3 times 3 times 3 times 16, and that's going to give you 432. And then you're going to combine all the t's, so you're going to have t times t times t, which is t to the 3rd. And then you would pretty much be in the same place you were in here, so you would just have to simplify. So I would again type in on my calculator 8 divided by 432, and that would give me 1 over 54. I would notice that the s cubed doesn't have any other s's, so it doesn't simplify. But I would also notice that the t to the 5th and the t to the 3rd have the same base, so I would subtract and get t squared, which I'm putting on the top because I always put my answer on the top for those. And you're done. Again, two different ways to do the same problem. Either way, you're going to get the right answer. We're going to go ahead and save number 5. Tomorrow in class, we'll brainstorm 2 different ways to do that question and see what we can come up with. Maybe we'll even come up with more than 2 ways. Thank you guys so much for watching and taking notes. Have a great afternoon, and I will see you tomorrow.